Alright, in this video, we're going to talk about solving linear equations. There's a couple different parts that go into this. Well, first of all, we have to figure out what does that part mean. What does a linear equation mean? Alright, so it's an equation where there's no kind of weird stuff happening with the x. Alright, so if we're talking about a linear equation in x, there's no kind of weird things happening with x. So this is going to be a linear equation because it just has an x and a y. This next one is not linear because we start having exponents, which are these little superscript numbers. All right, so this part, this x squared, means this one is not a linear equation. All right, so you're really just asking, there's anything kind of weird happening with the x. All right, this one, fine. This one's good. This one, as soon as there's something weird happening, there's a square root, which is not just a normal thing that happens to an x. That one's not linear. All right, this one might be a little confusing because there's nothing really weird happening with the x, but this big division bar, all right, division bars with variables automatically make kind of really weird things happen, so this is also not going to be linear. And the last one, all right, there's this 1/2 in front of the x, but to the x itself, right, the 1/2 is kind of separate from the x because there's just some number in front of it, just like we have just a 3 there, just 4 there. So that's not actually something kind of weird happening with the x. This one is also linear. So exponents, square roots, fractions where the exponent's in the fraction, those types of things will make it not linear. As long as we just have a single x with some numbers around it, even if the number is a fraction, those are going to be linear. So that's what we mean when we're trying to solve a linear equation, kind of the simplest type of nothing kind of crazy is happening with the x yet. All right, so our general strategy for solving these types of equations, you want to isolate the x. Isolate just means get it by itself. And we're going to do this by just slowly undoing all the other things that are near the x. All right, another way I like to think about it is you get the x's together. And then get rid of extra stuff. So we'll see what this means kind of in the second example. Right. But this is one of those things, it's just easier to kind of see in the example than kind of trying to figure out in words what we actually mean. Right. But isolating is a big one. Right. It's not solved unless the x is all by itself on one side. All right, so if our example is 3x minus 6 equals 12, our goal is to get this x all by itself. All right, so what we need to do is we need to get rid of the 3, and we want to get rid of this 6. All right, and once we get rid of those things, on the left-hand side, the x will be all by itself, and we're good. All right. Generally, you do these things by kind of getting rid of the things farther away from x first. All right, so the 3 is right next to the x, so we're going to get rid of the negative 6 first. How do we get rid of a minus 6? We do the opposite of it. We add 6. Because minus 6 plus 6, those things are just going to cancel out, and they won't be there anymore. But we have to remember to balance our equations. If we do one thing to one side, we also have to do it to the other, so I'm also going to add 6 to the other side. So now my equation, the left-hand side, is now just a 3x, because those 6's disappeared. On the right-hand side, 12 plus 6 is 18. And now the last thing I have to do to get the x completely by itself is get rid of that 3. Right now I have 3 times x. What's the opposite of multiplication? It's division. So I'm going to divide both sides by 3. And the reason I divide by 3 is because here those 3's cancel and I just get x. On the right hand side, 18 divided by 3 is 6. All right, so our final answer should be x equals 6. One good habit to get into is to use your answer in your equation and make sure it makes sense. So if you're really curious, if you're taking a skill check or something like that, if you're really curious if the answer you got is actually right, you can always plug it in and make sure. So 3, x, I think it should be 6. So if we simplify this left-hand side now, 3 times 6 is 18. 18 minus 6 is 12. And 12 is equal to 12. So that's how we know that's actually right. The answer x equals 6 is right. Here's another example. All right, we're going to solve this equation. The only difference is now we have x's on both sides. So the only thing that's really going to change in this one, we can't just kind of undo everything with the x's, or we'll still have x's everywhere. So here we want to get the x's together. That's our first step, to get the x's together. So right now, there's x's on both sides of the equation. I'm just going to pick left or right. There's nothing right or wrong about picking either one. So let's say I want to get the x's on the left. So I'm going to make sure all the x's are over here. How do I do that? Well, right now there's x's over here. How do I get rid of a 7x on the right if I subtract it? Let me do it in red. Then 7x minus 7x cancels. But I also have to make sure I do it on the left-hand side as well. 2x minus 7x is going to be negative 5 of them. So I just pick left or right. Again, there's no right or wrong to if you choose left or right. I just chose left for this example. But now you can see that I got all the x's together. Now it looks just like the last problem we solved. To undo this, now I get rid of the 4 first. Undoing a plus 4 is a minus 4. And the last thing I have to do to get rid of that negative 5 in front of the x is divide both sides by negative 5. And x is going to be negative 12 over negative 5. There's 2 negatives on the top and bottom. They just cancel it out. So I just get positive 12 over 5. This one, because your answer is a fraction, it's a little bit more tedious to plug in. You could plug it in and just make sure that this answer is correct. But as long as you're comfortable that you're balancing both sides of an equation as you go, the answer you get down at the bottom will be correct. It's always just a little bit more tedious with fractions. It'll take more steps that I'm not going to do in the video just to make sure that that answer is correct. All right, so here's your turn. Solve this equation. 2x plus 4 equals 10. And here's the answer I got. Again, when you're solving equations, technically in infinite different ways you could go about it, but in terms of the way that we did it, subtract the 4 first. I had to get rid of that 4 on the left, then divide by 2, so you get x isolated all by itself. And that's equal to 3. And 3 times 2 is 6, plus 4 is 10. So if I plugged it back in, it would confirm that this is the correct answer, x equals 3. All right, this last example and kind of the second half of this learning objective goes back to one of the objectives from the fractions unit, and just what happens if I start mixing in fractions with my equations. You can solve these using your principles of fractions, adding fractions, multiplying fractions, stuff we already covered. But there is a trick to kind of just get rid of the fractions, and that way you're not dealing with fractions as you're trying to solve an equation. And the way you can do that is if I take 1/3, and, well, any fraction really, and I multiply it by whatever the bottom of the fraction is. So I'm going to take 1/3 and multiply it by 3. What happens? Well, the 3 goes on the top, and then the 3 and 3 cancel, and I get 1. So basically, if you multiply a fraction by the bottom, the denominator of the fraction will go away. All right, so I'm going to use that to my advantage in this equation. I just have to remember, like we always says, we have to keep our equation balanced. So if I want to multiply this 1/3 by 3, I have to multiply everything in the equation by 3. Right, so if the left hand's all multiplied by 3, that's the same as the right hand being multiplied by 3. When I say everything, I'm going to take 3 and multiply it by this first term and the second term, and over here it's just multiplying by the one thing. So 3 times 1/3 x, just like we know that 3 and that 1/3 cancel, and that's just going to become x. And 3 times 3 is 9. On the right-hand side, 3/4 times 3. Well, 3 is the same thing as 3 over 1. So we get a 9 on the top and a 4 on the bottom. All right, so using that denominator of that fraction to our advantage, making sure you multiply everything by that number, you get an equation with one less fraction than before. Because there was a fraction in front of the x, now there's not. I'm just going to do the same thing again. I'm going to multiply everything by 4. Because now, if I do that on the right-hand side, the 4's cancel, and I just get 9. On the right-hand side, 4 times x is 4x. 4 times 9 is 36. And now it looks just like the other examples we've done. It's straightforward to solve. I add 36 to both sides. And 4x is going to be 45. And then divide by 4. 45 over 4. and 45 and 4 don't share any common factors, so that's our final answer. So although we did get rid of the fraction this step, our final answer still has fraction, and that makes sense because our original equation had a bunch of fractions as well. All right, but this is a way you can solve equations that have fractions by kind of just doing a couple steps, depending on how many fractions there are, a few steps, to get rid of the fractions first, and then you can solve it the way you're kind of more used to if there wasn't fractions to start with. All right, so here's your chance to do one on your own. There's just one fraction in this case. All right, figure out a way to get rid of that fraction. All right, and then solve the equation. All right, on the left here is kind of how I would have done it using the same properties before. So I multiply everything by 5 because that's the denominator of the fraction. As I get a 5x, 1/5 times 5 is 1, 7 times 5 is 35. All right, then I subtract 1 divided by 5 to get to this final answer down here. This one, you might not have to do this one because I could just subtract 1/5 the other side. X is already isolated, and then I just have to use my properties of subtracting fractions to get the same answer. So 2 different ways to get to the same answer. All right, but as long as you're getting there, whatever way works for you, then that's a good way to go about the problem. All right, so your multiple choice question, is x equal 4 a solution to this linear equation? So again, think about what it means to be a solution, how we checked it earlier in the video. I check it this solution and then put true or false. And after you get done with the video, if you understand everything, move on to practice problems. And when you're confident doing practice problems, you go to the skill check for this learning objective.